We feel that we were incredibly fortunate to be awarded the survey of the Chalky Preservation Inlets. It is essentially one of the most beautiful parts of New Zealand and indeed the world. In mid-2013, IXSURVEY was awarded a large survey contract by Land Information New Zealand to undertake a Multibeam Echosounder survey of the Chalky Preservation Inlets. LINZ has identified that a large number of cruise ships wish to start navigating the waters of the Chalky Preservation Inlets, and for them to do this safely, a full seafloor coverage survey was required.
The area was previously surveyed approximately 15 years prior using older but modern technology at the time. Well, the technology nowadays allows us to cover the seafloor to 100% coverage, so we know exactly what is there.
In December of 2013, we mobilised a small team to undertake some geodetics and tidal infrastructure establishment in the Chalky and Preservation Inlets area.
There are a lot of unsurveyed areas within that actual brief, areas which the previous survey had never actually achieved. So we needed the right vessels to get in there and to complete the job, and we believe that the two vessel solution which we selected was ideal. The project presented a number of challenges. Extremely remote area, so there was no fuel, no stores, so we had to tackle that in the right way.
Incredibly remote. The area has no logistics whatsoever. There's no road, there's no rail, there's no airport. So all fuel and food and personnel reprovisioning were undertaken by a third resupply vessel.
One of the other challenges of the project was sound velocity and the freshwater impact on sound velocity. So Fiordland has a lot of rainfall, up to about 8 metres of rainfall a year, I think, and what that does is provide a freshwater layer sitting on top of this salt water.
In order to combat the freshwater layer, it was decided that an automated sound velocity profiling system would be fitted to each vessel to reduce the amount of downtime required on a daily basis to undertake sound velocity profiles.
The other benefit of it was that because we didn't have to stop, we could conduct more sound velocity dips if we thought we needed them. It was just a matter of going out, activating the sensor, capturing the data and storing that away for later post-processing.
So the use of these automated profiling systems allowed us to undertake the survey for a lesser cost than we would have otherwise been able to achieve.
We saved time, and we also added to data quality because we could conduct more dips and use that for correcting the bathymetry at the end of the project. One of the technical challenges we approached with this project was that the fjords are very deep and there's not a lot of water flow in and out. So what that means is that the rainfall and the sediment comes down off the hills and is actually on the seabed, and it's very deep and soft. For echo sounders, we rely on reflective surfaces to get the sound back. We found that we couldn't actually reach the bottom in some of the deepest parts of the survey area with the equipment which we had on site. So what that required was to bring in new equipment, flew in equipment from Aberdeen up in the UK, flew that to New Zealand and then put that on a helicopter from Te Anau, flew it over the hill and provided that to the vessels. For this project, it was important for us with the two vessels and having them operating remotely is to having trusted people in each boat so that they could conduct the survey under our charge surveyor's instructions. It was important, otherwise we would lose efficiencies.
The personnel assembled for this particular project comprised a majority of IXSURVEY personnel. We had 3 senior surveyors involved and a couple of our junior surveyors and a survey engineer.
So by manning it this way, it ensured that we could maintain our data quality, meet the standards and meet our expectations and deliver the results for the survey.
The survey posed a number of significant challenges, both logistic and operational, and through good planning, excellent people and good equipment, we were able to meet all of these challenges and gather an exceptionally high quality data set. The survey took approximately 45 days to complete, and in that time each vessel surveyed a combined 4,000 line miles. The Chalky Preservation Inlet survey was last surveyed by the New Zealand Navy using traditional technology such as single beam Echosounder sonar. And this means that They're not actually insonifying the seafloor between the lines navigated with the survey ship. The benefit of the technology we're using is we're getting full seafloor coverage, and as a result of this new technology we're able to detect a charted feature 6 metres deep, which actually was positioned between the lines of sounding undertaken by the Navy 15 years ago. So what we've actually found is a rock that could have caused a significant environmental and marine incident, and if this prevents one grounding or one environmental disaster, it's been well and truly worth the time and effort invested by the New Zealand Government to have it undertaken.
And overall, the area is thoroughly surveyed and is safe for navigation.